A mesmerizing and awe-inspiring spectacle unfolded on Monday as our home star's sun unleashed giant but extremely faint plumes of plasma over its surface. This fascinating phenomenon followed a powerful solar flare that erupted with unprecedented intensity. The entire event was beautifully captured on a stunning new photo display, where these spectral loops remained like the ethereal echoes of a departing solar storm. As we begin this exciting exploration with a video presentation, we dive deep into the complex and mysterious world of solar storms. We focus strongly on the post-flare loops that persist after these dramatic solar flares. Despite the vast scientific knowledge of our sun, the precise mechanisms governing the formation and preservation of these ethereal remnants remain a fascinating mystery. During this in-depth presentation, we will take advantage of the latest advances in visual media, exciting photos, and compelling videos that not only show the amazing beauty, but also highlight the immense power of our nearest star. Our overall goal is to unravel the complex scientific backgrounds behind these celestial events. In doing so, we try to explain why understanding solar dynamics, such as solar flares and their consequences, is crucial to understanding the behavior of the sun and the dynamical functions affecting our solar system. Get ready for an immersive journey into the core of our solar system, where the sun reigns in its celestial majesty. On this historic Monday, January 29th, 2024, the sun unleashed a massive solar flare, an event of unprecedented significance in recent history. This monumental flare stands out among the most significant flares recorded in the last decade and highlights the sun's extraordinary capacity for unexpected and powerful bursts of energy. This event not only fascinated astronomers and solar physicists worldwide, but also emphasized the role of the sun as a dynamic and unpredictable celestial entity. The flare, which began on January 29, 2024, is a stark reminder of the sun's inherent instability and its profound effect on space weather. Its powerful radiation and magnetic disturbances have far-reaching consequences, affecting everything from satellite communications to Earth's power grids. Understanding and predicting such solar phenomena is essential to securing our technological infrastructure and preparing for potential disruptions caused by space weather phenomena. In addition, this unprecedented solar flare event produced some fascinating phenomena, including the formation of post-explosion loops, which are residual structures of plasma suspended in the solar atmosphere. Cooler and darker than their fiery origins, these loops are permanent signs of the sun's turbulent activity. They challenge scientists with their persistence and complex compositions, encouraging continued research into the mechanisms that drive their existence. Basically, the solar flare on January 29, 2024 not only attracted the scientific community, but also provided valuable information about the dynamic behavior of the sun. It acts as a catalyst to advance our understanding of solar physics and space weather prediction. By studying these phenomena in detail, scientists try to unlock the secrets of the sun's magnetic dynamics, plasma interactions, and wider effects on Earth and beyond. As we continue to unravel the mysteries of our celestial neighbor, the sun, we are reminded of its dual nature, both terrifying and potentially dangerous. Our research goes beyond mere observation. It is an effort to deepen our knowledge of the universe and to use the power of the sun for the betterment of mankind. Join us as we navigate through solar storms and post-explosion loops and forge new paths to scientific discovery and technological innovation. To understand the magnitude of this event, it is important to understand the nature of a solar flare, the sudden release of intense radiation and magnetic energy caused by the rotation and instability of the solar magnetic field. This solar flare, classified as an X-class flare, the most powerful, lasted about 15 minutes. The sun's radiant glow was so intense that it defied its appearance on the other side of the sun, making it visible to the naked eye from our perspective on Earth. The show did not end at sunrise, however. This triggered an additional event called a coronal mass ejection, CME. This phenomenon involves a huge cloud of plasma and magnetic fields ejected from the sun at a remarkable speed, estimated to be about 10 times that of Earth. The CME was traveling at an amazing speed of about 2,000 kilometers per second, Although the CME was directed away from Earth, its effects were still felt on our planet. The disturbances it caused in the Earth's magnetic field caused geomagnetic storms, which caused possible disruptions to satellites, power grids, and communication systems. In addition, the CME strengthened the solar wind, the stream of charged particles flowing from the sun. This solar wind interacted with Earth's atmosphere to create the fascinating northern lights, or aurora borealis, that can be seen around the world. One of the most exciting images documenting a solar storm was skillfully captured by Argentine amateur astrophotographer Eduardo Schab. Using a special telescope and camera, he captured the faint curls of plasma that remained above the surface of the sun right where the CME erupted. These loops, scientifically known as afterburn loops, form the remnants of plasma ejected into space during a CME. Despite their initial fiery nature, these post-combustion loops show significant deformation, cool significantly, and form a complex. They are tangible signs of the complex interaction between the forces of the sun and the vastness of space. In conclusion, studying the core of this solar flare and its subsequent coronal mass ejection reveals not only the stunning beauty and power of our sun, but also the complex dynamics that govern its operation. By delving into the science behind these celestial events, we gain valuable insights that contribute to our broader understanding of the universe. So join us on this extraordinary journey as we discover the mysteries of space and see the amazing phenomena left behind by the solar storm. Despite their cooler and dimmer appearance compared to the surrounding sun, which makes them hard to see, post-flare loops showcase intricate shapes and structures. This photo provides a rare and remarkable glimpse of the aftermath of the sun's post-flare loops. As mentioned, following the solar flare and the coronal mass ejection, CME, something else captured the attention of scientists and observers on the sun's surface where the flare originated. Faint and twisted loops of plasma appeared to hang in the air. These are the post-flare loops, remnants of the plasma ejected into space during a CME. These loops, much cooler and dimmer than the surrounding sun, are hard to see, yet they are stable and can endure for hours or even days after the flare. The question of how these loops form and persist for an extended period remains a puzzle for scientists. One possible explanation is magnetic reconnection, a process occurring when the sun's magnetic field lines break and reconnect in a different way, releasing energy and heat, creating the flare and the CME. Alternatively, it can form new magnetic loops that trap some of the unused plasma, eventually cooling down to become the post-flare loops we observe. Another plausible explanation is chromospheric evaporation, where the sun's lower atmosphere, the chromosphere, is heated by the flare, expanding into the upper atmosphere, the corona, creating a surge of plasma that fills existing magnetic loops, forming the post-flare loop. While the explanations put forth for the formation and persistence of post-flare loops are plausible, they remain inconclusive in scientific terms. Researchers emphasize the necessity for further observations and simulations to rigorously test and refine these theories. This ongoing pursuit is crucial as it aims to unravel one of the sun's enduring mysteries, namely how these intricate structures evolve and endure in the wake of solar eruptions. The study of post-flare loops presents a captivating puzzle that continues to challenge our understanding of the sun's dynamic behavior. These loops, cooler and dimmer than their surrounding solar environment, offer a window into the complex interplay of magnetic fields, plasma dynamics, and energy transfer processes occurring on our closest star. Their resilience and persistence for hours or even days after a solar flare highlight their significance as enduring remnants of solar activity deserving of meticulous scientific inquiry. Beyond their immediate aesthetic allure, the solar storm and subsequent post-flare loops observed on January 29, 2024, hold profound implications for our understanding of solar physics and space weather. These phenomena serve as poignant reminders of the sun's immense power and influence, prompting deeper investigations into its mechanisms and impacts on Earth and space-based technologies. In scientific circles, the events of January 29, 2024, mark a notable occasion for both observation and analytical rigor. They underscore the importance of continuous observation and data collection to decipher the complexities of solar dynamics and their implications for our technological infrastructure. By studying these phenomena in detail, scientists aim not only to enhance our predictive capabilities regarding space weather, but also to fortify our defenses against potential disruptions to satellites, power grids, and communication systems. Moreover, the study of solar storms and post-flare loops contributes significantly to our broader understanding of stellar astrophysics and plasma physics. It provides insights into fundamental processes like magnetic reconnection, plasma heating, and the dynamics of coronal mass ejections. These insights are not only relevant for space weather forecasting, but also for advancing technologies such as nuclear fusion and plasma confinement, which seek to harness the sun's energy potential in a sustainable manner. In conclusion, while the solar storm and post-flare loops of January 29, 2024, captivate us with their visual splendor, they also beckon us to delve deeper into the intricacies of our celestial neighbor. They inspire ongoing scientific inquiry and innovation, inviting us to unravel the mysteries of the sun and leverage its power for the benefit of humanity's quest for knowledge and technological advancement. Examining these events offers valuable insights into the sun's activity, crucial for various reasons. Firstly, understanding the sun's behavior aids in predicting and preparing for space weather events that can impact communication systems, power grids, and satellites. Moreover, studying these events contributes to our broader comprehension of the sun's dynamics, influencing space weather forecasting and space exploration endeavors. As we conclude our journey through the captivating phenomena of solar storms and post-flare loops, we gain a profound appreciation for the complexities and wonders of our solar neighbor. The solar storm of January 29, 2024, serves as a testament to the sun's dynamic nature and its far-reaching influence on our technological society. The persistence of post-flare loops as enduring remnants of solar activity challenges our scientific understanding and beckons further exploration. By investigating these phenomena, we enhance our ability to predict and mitigate the impacts of space weather on our technological infrastructure, ensuring the resilience of communication systems, power grids, and satellites. Furthermore, the study of solar storms and post-flare loops contributes to the advancement of stellar astrophysics and plasma physics. Insights gained from these events deepen our knowledge of fundamental processes such as magnetic reconnection, plasma dynamics, and energy transfer in the sun's atmosphere. These insights not only inform our understanding of the sun, but also have broader implications for technologies like nuclear fusion and plasma confinement. As we continue to unravel the mysteries of our sun, we are reminded of its dual nature, simultaneously awe-inspiring and potentially hazardous. Our journey of exploration extends beyond mere observation. It is a quest to deepen our knowledge of the universe and harness the sun's power for the betterment of humanity. In essence, the solar flare and post-flare loops of January 29, 2024, serve as both a captivating spectacle and a catalyst for scientific inquiry. They invite us to delve deeper into the sun's intricate dynamics and leverage our understanding for technological innovation and space exploration. As we navigate through the complexities of solar phenomena, we embark on a journey that transcends our planet, reaching for the stars and beyond.